We now begin construction of the tabletop, which comprises 6 components in total. The 3 wider components comprise the centre panel, and it's bounded by 3 mitered rails. Now, when I cut these pieces, fortunately I found that they were absolutely flat. To be doubly sure, I put the lower face through the jointer and completed the upper face on the planer. Now, we want seamless joints when this is all completed. So normally it would be done, the edges would be done in the jointer. However, I have a method I've used for years, very happy with it, so I'm going to continue with that. And I'll just show you the one mating surface. These are marked. This is the 3 centre components, and I marked these 1 and 4, 2, 2, 3, 3 for these meet, and I'm just going to show you this one. Now, when you're doing this, you have to understand that it's not just these 2 faces that are important. When you do it this method, I'm going to show you this is also important for these 2 here, and this is important for these, because these 2 faces go against the fence, and that's another thing. You must have a reasonably good fence to do it this way, a good accurate fence. So let's get started. Now, in order to obtain seamless joints, you have to calibrate your table saw and make sure your blade is absolutely vertical and 30 and 90 degrees to the tabletop. Now, as I said before, we use these 2 thin slats marked at the top, 2 check marks. Take a cut, bring your saw blade up to the close to the highest point. Now, after that, clean this up with sandpaper so that you don't get a false reading. Place it on the cast iron tabletop. Now, I've already corrected this one, so it's absolutely... Now, as I've said before, if your blade was out a degree, you're going to show 2 degrees on here, or if it's 2, it's going to show 4. So it's a really good way of calibrating your table saw. And these are the 2 centre panel workpieces that I'm going to show you doing this seam here. As I said, this is 1, 2, 2 and 3. And a couple of important things here. I take a fine cut. I usually go for a 32nd. And the second thing about that is, after you've taken the first cut, don't rotate it that way, your workpiece. Rotate it this way and do the other face. So that's the first thing. Okay, now this, as I said, this one here, this face here is just as important as these 2 here, because this will eventually go up against the fence in order to cut this one, so it's very important. That's pretty good, but it's not. Yeah, that's almost perfect. But if it's not perfect, just keep doing it. Just take off it and keep rotating it. Take off for 30 seconds, rotate it, rotate the other one, and just keep going in that direction, and you'll finish up with a seamless joint guaranteed. Now the next step is to glue and join the three sections comprising the centre panel. Now before I begin, what I do is I trim all three ends here to make sure that they're absolutely 90 degrees to the two edges. Now the reason for that is that once these are all joined, I'm going to be aligning from the top on all three down, so that when they're actually joined, these three edges will be flush, and it makes it easier to align in the table saw fence and trim the other end. Now these components are 7/8 thick, and as you could recall, the centering for a 7/8, a half to 7/16 minus 3/8 is plus a 16th. So what we do there is we take a 16th spacer and we add it in between the reference bracket and the reference block, and that will center us exactly on the 7/8 timber. Now I have already drilled some of these holes in order to save time, but to show you the referencing marks, this is 2, 2, 2 in the top edges here, and an X on these surfaces here, and the same here, 3, 3 and 3 at the top here, and X's on the surfaces to be drilled. Now I'm going to drill 6 along here. Probably a bit overkill, but better that way than the other way. So install this like this. Now the check mark is here, or the number 2 is here, number 2 is on the top, and we're drilling into this face. So again, we're going to be using the 16 spacers in, and we're going to be using the indexing pin for referencing. So we'll put the indexing pin in the number 1 bore, bring it along, hold it firmly. Now we're going to drill, in this case, 4 and 5. Now this extended distance gauge is set at approximately 9 inches. Make sure it's level and centered, and tighten up. And on this occasion we're going to be drilling 1 and 2. Procedure again in the last bore. Firmly against there, tighten up. And again we're going to drill 1 and 2. And that's that finished. Now I'm about to dry fit the centre panel, and I've installed 12 dowels. Now that's not something I'd recommend. Normally for dry fitting I recommend approximately 50% of the dowels. But anyway, I'll probably have trouble getting this apart, but anyway, that's just for demonstration purposes. There's a 2 here, 2 there. 3 there, 3 here. Bit open here. And that's it finished. This one, when it's clamped, will be seamless. This is almost seamless now. So that's, and we're pretty well flush up here, so that's just the way I wanted it. Now the centre panel is finished and all the edges and ends are milled and they're true with each other. Now I'm going to join 3 mitered rails to the outside, like so. I don't know if you can see these markings. These will follow it like that. And this has a routed profile, which you don't have to do. You can leave it plain if you like. I'll just round off the. But this routed profile is called a windowsill, which is not very exotic, but I actually find it's a really nice profile. Now, several things to note here. You've got to get your thicknesses and your widths identical in all 3 parts, or the profile won't mate and match together the way you want it to. And also, it's important to, if you're going to do the routed profile, to do it before you start joining the 3 parts. This is really important too. Now, I'm going to join this with pairs of dowels, like 2, 2 and 2, and the same in the front, 2 here, 2 in the centre there, same over here. And I'm also going to join the miters once they're fitted with a dowel which will be placed like that across the diagonal. Now the reason for that is if you don't do it, normally it would be that direction, but we're going to do it in this direction, which follows the axis of these other dowels so that we can place it together. Now I'm not going to spend a lot of time on the router use, but for the benefit of newcomers to woodworking, I'd like to point out the following. The first thing is, whenever you're working with changing bits on a router table, always make sure the power's off. Now one of the first things you've got to know about it is that the top face always goes down on a router table and you pass through. And the other important thing is, very important, the router bit rotation is in this direction. So you always want to work against router rotation, never with it. If you work with it, the workpiece can be drawn into the bit as can your hand. So it's always essential to work against rotation when you're using a router table. Now, before you start, I close up the fence so that the fence is as narrow on the router bit as you can get. Just beyond the router bit. That prevents any undue movement of the workpiece as it's passing through. Now, never try and take a huge cut with a router table. Just take three or four small passes each time. And again, never hesitate. If you're going to stain the piece and you hesitate, it'll burnish the surface and adversely affect it, and then when you stain it, it will show. Now one more thing, or one or two more things. If you're doing a cross cut, there's 2 ways to approach this. If you're doing a cross cut and you want to avoid tear out at the back end here, you can insert a backing block, and that helps to prevent tear out. Also, what you can do if you're doing cross grain cuts, Always do that first before you do the long grain, because the long grain will then sometimes take out that extra cut. Now, in order to accurately determine the position of the various miters, we have to first find the final position of the 3 mitered rails. So we begin with the reference marks, 1, 1, 1, 1, X on the surfaces to be drilled, 2, 2, 2, 2, and again X on the surfaces to be drilled. Now, I've already drilled this end of the centre panel, and I'll now do the 6 bores for the opposite workpiece. Now, the check mark of the number is there, 2. Is it flush at the end? This is not too important because I'll be trimming this off afterwards. Now, to follow the sequence here, we're going to drill 4 and 5, 1 and 2, 1 and 2. For these, same as these settings here, I've set the distance gauge at 4/16. Make sure it's level and centered. Now I'm going to drill 1 and 2. Same again into the last bore. Again 1 and 2. Now, as you can see, there's 6 here, but I'm only going to install half that number so that I can get it apart again. That's the final position. We have to take this one off and do the centre one, leaving 3.5 each end, because this is 3.5 wide, it's a 45, you have to leave an extra 3.5 here and a 3.5 there. So we take this one off, fix this one in, take that one off, fix this one in, and we have all the positions, exact positions for the beginning of the miter. Now, dowel positioning in the miter is very important. It has to be very accurate, and it also has to be done before you cut the miters. I mean, as I said before, the dowels are all in this axis, and the one in the miter has to be in the same axis to get the thing to come together. But now we know the position of the exact position of each rail. This is simplified to a large degree. Now we know exactly the position of this. This is not really necessary, but we can lightly clamp it, just very lightly, just to position it properly. Now, what we do here is we have to reference to this face here to get the proper distancing. And this is the reference face. And now we bring Dowelmax right up against the centre panel, firmly, and clamp. Now we're going to be drilling through number 3. And that's that one done. Now I've already drilled this one which matches that, so I'll drill the other end. The same procedure, almost. Now this time we're going to reference against this inside face here, which of course matches the the outside of the centre panel. That's good. And you have to drill quite far in. I don't know if you can see the diagonal representing the mitre cut, but you have to drill in quite far, just approximately 4¼ inches to get a space for the dowel. And that's that finished. We are now ready to join the 3 mitered rails to the centre panel. Now you'll remember that when all these rails were dowelled and set in place, we were able to mark the position of the inner mitre on all surfaces. Once again, this one here. Now the best way I've found to approach this is it requires some patience. The best way to approach it is to start off with this longer rail in the front here and then fit the 2 side rails. They're easy to play around with. So this one's finished, it's dowelled, it's dry fitted, and you want to make sure that when you're finished there's no ridge. I can't feel a ridge between this surface and that surface, and that's just perfect, same on both sides. Now, to begin with this one, I'll use this as a substitute. Begin with this one. We begin by taking a test cut on the 45. So you set your gauge up at 45 degrees. It probably won't be, but set it up approximately. And you take a small cut, maybe certainly not up to the line, just an inch away from the line, and take a cut. And then we measure that I used this gauge and find out just how we've landed and then adjust it accordingly and just keep adjusting this miter gauge until you get the cut just right. And it doesn't have to be exactly 45, but it has to be close to 45, because as you can understand, if it's slightly more or less than 45, I mean a few minutes, we can adjust the end rails to suit. So now once you get the angle close to 45, you can then start taking subsequent cuts up to the line, and then after that you've got to be a bit more careful until you and fit it with the dowels, and so that you get to that point where there's absolutely no ridge between this face here and this face here. Now, after that's completed and dry fitted, we come to do the two end rails. And once again, we have to have some patience here. We set our miter gauge to 45 or approximately whatever, and we take a cut. Usually I start about maybe an inch from where the inner miter is. This is the miter here, just about an inch or 3/4 of an inch from there, and we take a cut. Now, with no dowels installed, we fit this against here and we move it down until we fit it on here. And now I find from this I have to take a little off the tip. So we adjust the miter gauge accordingly, take another cut, come back, make sure it's firmly up against and square and true, and move it down and keep adjusting it until you've got an absolutely perfect matching edges. And then after that, now you can go maybe a 1/16 off the inner mark, and then keep taking cuts like that. Less and less of an amount taken off each time, and finally you install your dowels and you fit it until it matches perfectly. And you do exactly the same on the opposite side. Now the left rail is now complete, and we're going to dry fit it. I'm only installing 50% of the dowels on this test because they're really snug dowels, and if I install all of them, it will be really difficult to get apart. I've also installed the one on the miter. Now this is really important to stabilise the miter. I really like to do this. It's a wee bit of extra work, but it's worth it. That's it finished, and I'm really pleased with that.